Hello. So this video is just going to cover nested loops. Both of the homework and the lab assignment this week cover nested loops. I don't believe either of our lectures for the week actually cover it, or if they do, they just quickly touch on it. So I just wanted to make sure you had an introduction, maybe take a look at some different ways of using it or thinking about it. So what are nested loops? Is the obvious question. So as you might expect, nested loops are you have a loop inside another loop. And why might you want to use nested loops? So typically you need them if you have two dimensions of data. So if you think about it, if you have, a sequence of numbers, like 1, 2, 3, 4, 5, and you want to process those, that's one dimension of data. So if you have two dimensions of data, the obvious thing, other than a sequence of numbers, is to have maybe a table, like tabular data. So you have, in a table, you have rows and you have columns. So there's your second dimension. And so you can even kind of expand tabular data to contain different kinds of data types. From the perspective of like what we're looking at it. Like not everything has to be in a box, not everything has to be the same width and everything. So kind of the similar thing that it still sort of maintains the tabular structure, but maybe the input itself may not look quite so tabular, CSV files, which are rampant and common everywhere. So let's go ahead and take a look at something like that. I went ahead and I was thinking sometimes, it's not enough to have made up data and play with made up data. And it's nice to be able to play with something real source. So what I did is I thought about what's out there right now that is just producing massive quantities of data that is going to be able to, we'll be able to look at. So I just searched for World Health Organization CSV data and I popped in here. So here I have a data download. So if I click my data download, I can sort of pop over here and look at that. And you can see that there's multiple data sources. So we might just grab this one. Since I am just popping over and downloading data on the internet, sometimes it is nice to make sure, excuse me, that you have permission to access said. So the WHO, they're completely fine with people using their data, and they kind of hope that you'll use their data to spread word. So they provide authorization as long as you don't use their resemblance or something. So we're free to use this data for just processing and playing with. We can't sue them about it. So let's go ahead and grab the data. So right here we have this COVID-19 dot WHO. So how do I get this onto the server? So it has a URL. So I'm first going to copy the URL. Let me go somewhere where I want to put it. So this will also be where the files will live after I'm done. So public, where do I want it? Nested loops. So you can see I'm in my home directory, public nested loops. So a utility for getting, downloading a file, a single file to it. The simplest one probably is wget. So if you look at the man page for wget, the options are just wget. You can provide additional options that are defined down here, or you can, and then you just provide the URL. And by default, it's just going to give you the name of the file. You can see the name of the file here. It is the name of the CSV, so that's going to be fairly well formed. So I'm okay with that. So I don't have to look further to see if, I have to change what the file name is. So let's go ahead and wget, and I'll paste my copied something else. There we go. Paste that in. You can see it'll do a little processing. It grabs it. When I do ls, the file's there. And you can see, if I do an ls, we have almost 8 megabytes. So it's a little bit bigger than some of the stuff we've been working on so far. But kind of the cool thing about computer science files is that the size of the file doesn't really matter. It's kind of, what you can do for one thing, you can do for many things. And that's kind of the benefits of using loops. is that it sort of lets you take what you do for one thing and apply it to many. So if we look at this, it looks like it's fairly uniform, right? So everything here. But if I know anything about CSVs, well, it's that they're separated by commas. And if I know anything about people that like writing and putting in data into CSVs, it's like they sometimes like to use commas. So I have my suspicions that this file is maybe not perhaps well suited, where I can't just kind of glance across and make sure that there are, I can't just split on commas and grab each individual one. But I don't know, and it's 8 megabytes. I don't necessarily have time to go through and look through everyone. So I want to write a program that will kind of give me a quick just a quick test just to see if they use more commas inside their text and if I need to do something special when processing it. So obviously I don't want to do it. If I use word count and look at it, probably give it the file name, right? I have 181,780 lines. So I don't want to individually look at 182,000 lines. So we'll write a Python program to do it. So what should we call this file? How about let's see, check CSV. Okay, so we'll write a program called CSV that will check to see if a CSV is accurate. Okay, so let's go ahead and if name equals we'll call this our main. All right. So what do I want to do with this file? Before almost everything we've done, or everything we've done, has sort of involved we prompt the user and they type something in. In this instance, we are actually wanting to process a file that already exists. We can do that without using anything new. We don't need to know how to open a file and read a file or write to a file. We can do everything with our input command. So how do we do that? So I have this Python file and I have the other file. How do I get one into the other? So let's right quit this and look in here. Let's see what we have. So in the shell, you have the ability, one of the really useful things about Unix or Linux command line, the terminal, the shell, is it lets you sort of take output from one thing and put it into another. So the output can be from a file, it can be from the execution of a command, but basically we can take the output of one thing and put it into the other. So in this case, we just want the contents of a file. So we want to get the contents of our WHO file up here and we want to run it through this check CSV Python file. So for that, we can do, the Linux shells have redirection. And what does that look like? So if I want, if I just want to, dump the contents, I can use cat, which is, short for concatenate. And you can see it print on the standard output. So this is sort of what we're leveraging. So if I want to just dump it out, there we go. It goes crazy. Cut that out. So I want that, but I want to put it into our file. So if I were wanting to run it, I could say check CSV, and then I give it this sort of sideways caret, And basically this means anything over on this side gets put into what's over here. So that's what I could do. So it's the same thing up there. I don't have to just type cat in the file of it. I can do that. I can also do this, and then it'll read it from the standard input rather than just taking it from the file. So we're going to do the same thing. So when we run, we'll be able to run Python here like this, and there it'll go. So that's just a syntax error because I have my main just hanging out there. So what we want to do is we want to look at the file and we want to go for each line. We want to process each line. And what we're going to do is we're going to count the commas just to see if somebody put extra commas in there. So, and basically we want if everything, if it's valid and it's going to let us parse it normally just by using commas and not having to worry about them in the middle of the data, each one should have exactly the same number of commas. So what we're going to do, we'll drop up here in max commas and we'll set it equal to 0. Do it here. Max commas, we'll set it equals to 0. And then we want to loop over the lines in there. So we already know when you type input and you give your, when we've used input already, what does it expect? We provide a prompt if you want, and then we basically wait for the user to type something and hit enter. So that enter is a new line. And you can see in that CSV file that, you know, each row of data was on a new line. So we have the same sort of format. So we'll just roll with that. So what we need to do is we need to loop over that until there are no more lines. How do we get there? Well, let's not worry about what happens when we get to the end. We can always control it, and we can always control C to break out of it if we sort of have an input and it hangs waiting for something next. So let's grab our next line and see, we can say while next line is, let's just guess that it might be equal to an empty string. It's not equal to an empty string. So we want, in here, we want to do something. We want to process the line count commas. Then at the end, we want to go ahead and grab our next line. Process the line count commas. So how do we do this? So I think so far our for loops, we've shown how to iterate across numbers. So, you know, if we want to iterate from 1 to 5, you can say for I in range 1, 5. That'll go 1, 2, 3, 4. If we just give it a range 5, it'll go 0, 1, 2, 3, 4. So it gives us 5 items, with 5 being the non-inclusive upper range. But what we have when you grab each next line is just a string. So how do we process across those? So in Python, strings are actually iterable, just like our range, what we get from that. So if I have s is equal to a, b, c, d, e, f, g, so we can see my string is there. If I say for a character in my string, let's sort of print first the type of my character. And let's print my character itself. Let's see what this does. So you can see for each one, the class is always a string, and it's printing A, B, C, D, E, F, G. So we can see when I use the for loop on a string, it takes the string and it breaks it apart into a bunch of little one-character strings, and that gives me this. So think of these each as tiny little strings, but basically, if all we're doing is looking for a comma, we can just check as we iterate across it if one of them is equal to a comma. Hop back into our program. So we have this first loop. So right now, we are in a single iteration of the loop, and we want to iterate over the line. So nested loops is literally just a loop inside a loop. So for, let's call this each character in next line. Spaces. We need to first set our comma count equal to 0. I want to do this up here. So if our character is equal to comma, I want to increase my comma count. We'll increment it by 1. And then once I'm done processing this loop here, what I care about is if there is ever a new maximum, right? So we started the max commas at 0 up here, and the first time I expect there to be 1, 2, 3, 4, 5, 6, so 7 commas. And I'd hope there's 7 commas in everything if it's going to be easy for me to parse this. So each time I get a new maximum, I want to print it. So let's go ahead. I've processed it. I've counted all the commas. So this has been incremented. So at this point, I should have the number of commas that are in a line. So if our comma count is bigger than our max commas, we want to set up an output, new max commas per line, and we'll call it comma count. So we should see this at least once when it goes from 0 to 7, and we may see it more times. Let's go ahead and print that output. After we're done with our check, let's go ahead and grab the next line so that we can check that our next line up here. All right, so should this have everything we need? One thing we might be concerned about is that the comma count here is just going to keep going up and up and up and up and up. But you don't have to worry about that because each time you kind of go through the loop, this gets set to 0. So we process one line, we set the comma count to equal 0. We process a line, we increase it several times. We print if it's a new one. We grab the next line, and then we come all the way back up here. And then we set the comma count equal to 0. So we're sort of protected from this being going up and up and up. We can use this each time that we go through the loop, the outer loop. So now we have this thing. The one thing we may not be sure about is what happens how do we get to the end of the line? How do we know when we're done? So let's go ahead and try this. I probably didn't type everything correctly. So we'll go Python 3, check CSV, and we want to use the input of this file. All right. So basically, I said the max commas per line is 7, so I didn't do anything. What we also get down here is that there's an end of file error when I got to the end. End of file when reading a line. So let's address the new max commas per line first. So why is that happening? So basically, if I go through and it's 7 every time, I never updated my max commas. So what I need to do is after I check that I have a new max, I need to actually create a new max. Max commas is equal to comma count. And so the first time through, this should be set to 7, and then I'll set my max commas equal to 7. This one's outside the loop, so this one is not getting updated every time we go through the loop. It's only getting updated when we see a max comma, a new maximum here. So let's try that again. All right, so now we saw new max commas per line 7, new max commas per line per 8. So that tells us at one point, at least once, we found a line with 8 commas. So at this point, we know if we're expecting, there to be an equal number of columns in our CSV data so that we can put it into kind of a table and do filters or whatever we want to do, we have to do a little bit better processing. So we have to know that there can be commas inside it for this particular CSV file. And then, so let's deal with the end of file error. So we want to fix this. So that tells me that, when we get to the end of it, we don't just grab a new line like I guessed, right? What happens is when I run next line equals input and it gets to the end of the input, it's just grabbing, it sees this end of input character, and then Python, the input function is designed just to throw this error if it gets to the end of file while we're parsing it. We don't get the end of file when we're typing into the terminal because we always hit enter, so we always just give it another new line, and then we don't ask again. But when you're parsing sort of data that's already been supplied, when I'm doing, sorry about that. When I'm doing this thing right here, the shell, it drops this into it, and then it sticks an end of file character at the end, which is good because that gives us like a definite stopping point. I don't have to guess like when the file ends. I have a character that's telling me explicitly, and if I want to use input for Python, I can. So let's modify this slightly. Instead of grabbing the next line of input up here and incrementing it down here, let's have a forever loop. So basically, this will go forever until I tell it to quit. And instead of, let's get rid of this, instead of doing this down here, let me grab the next line here. Now, one thing is I've moved this in here. I still haven't messed with the end of file, right? I've done nothing to fix it, so I'm still getting that error. But what I can do is Python has a built-in way of trying certain things that we expect might give us errors. And in this case, it told us the type of error was an end of file error. So what do I want to do here? If I get to the end of file, that means I have no more lines to process. And I can go ahead and just break out of my loop. So when I hit break, it goes up to the nearest loop and it breaks out of it. Excuse me. So the hope is we've handled this, and basically once we get to the end of the file, we will see this error and we can just quit. We can go down here and type processing complete. So if we've broken out of the loop, we should we'll come back over here and it'll go processing incomplete. Run that command again. All right. So that is how you process 182,000 lines of data using nested loops.